All right, moving on to question number 9. All right, so question number 9 reads, what is the limit as x approaches infinity of sine of x? So the junior tutor reasons that the sine function is an oscillating function, right? If you graphed it out, its range will be between -1 to 1, right? So as a function approaches infinity, it does not approach a single value. Thus, its limit does not exist. So this is technically true, and the junior tutor is correct. So I'm going to use a different method of describing what the junior tutor wrote out here, okay? All right, so we're going to talk about the squeeze theorem again. So the squeeze theorem suggests that, let's say that we have a function f of x, okay? So if we can sandwich or squeeze this function between two other functions, let's say g of x and h of x, okay? And if the limit of h of x as x approaches, I guess, a number, let's say as x approaches infinity, for example, equals L, and also the limit of as x approaches infinity of g of x also equals L, then we know that f of x, that the limit of f of x, whoops, the limit of f of x as x approaches infinity also equals L. So this is what the squeeze theorem suggests. Is also called the sandwich theorem, okay? So we're going to use this theorem to try to find the limit of sine x, okay? So if the limit as x approaches infinity of h of x and the limit of g of x as x approaches infinity do not equal the same number, that means that the limit does not exist for this one. Okay, well, yeah. So we have our function, which is sine of x, okay? And we're going to fit it between our functions. Let me make this more neat here. So we have our function sine of x here, okay? So let's say that, let's fit it between these two functions, g of x and let's say h of x, okay? So what are our functions? What can our functions be? Well, let's say that g of x equals 1 and h of x equals -1, okay? So these two functions fit between our squeeze or sandwich sine of x, right? Because we always know that sine of x is, the range of it is between 1 and -1, right? The values. So therefore, we have -1 here, sine of x, and we have 1 over here, okay? So this is what our junior tutor is proposing, right? That sine of x, the range of it is always between 1 and -1, all right? So if we calculate the limit as x approaches infinity of -1 and the limit of x approaches infinity of 1, we get this. So of -1 is going to be -1. And the limit as x approaches infinity of 1 equals 1. So therefore, these limits, these do not equal the same. Sine of x does not have a limit, okay? That's another way we can reason that sine of x does not have a limit as x approaches infinity, okay? Yeah. So since the function is always oscillating, it's not going to approach a single number. It's going to go up and it's going to go down. It's always going to go up and it's always going to go down. And using our squeeze theorem method, we kind of figure that out, right? So yeah. So the solution is correct. Okay. All right, let's solve our last question.